change things up. But every year so far, I've seen an area and volume problem. There's never been a time since I've been teaching this that I have not seen it. So we believe that you will have an area volume. Now, College Board does like to change things up, so that might not happen. You will find it on multiple choice. Whether or not you see it in FRQ or multiple choice, it will be there. Okay, so I thought we would work on that today. We start with 2012, 2011. Another thing that I think is pretty certain, and it's usually in the first couple problems, is the position, velocity, acceleration. Well, I did one. I haven't done a lot in review, but you might have been doing it. And then, but you know, they're not all independent problems. So in this problem, they might have a max-min question. And so then that means you need to know the max-min existence theorem. If you have a closed interval on a continuous function, you're guaranteed both an absolute max and a minimum. So they can embed some of these things in other things. They actually did a tangent line in 2011 in the area volume problem. You will have to write the equation of a tangent line. So when you do your slope, make sure you don't do it upside down. I've seen it upside down many times. Y minus y1 equals m, x minus x1.
What do you mean upside down?
It's the change in y over the change in x. Why? It's because the tables are upside down.
Rise over what?
That's, yeah, but the tables are upside down, and you know, you will, no matter how much you prepare, you will be stressed. Okay, there's a bunch of theorems. No? I need to do instruction. Okay. What? Wasn't mine. Okay. Okay, guys. Mean value theorem, intermediate value theorem, average value of a function. If you go and look at the exams, you'll see those. And they're all going to be mixed up. They might have a max-min problem in there. Average value of f of x, which is the integral from a to b of f of x dx over b minus a, and average rate of change. This is the mean value theorem.
When you're doing this, is it
So let's focus on this. The answers are there for that. And that's equal to f of b minus f of a all over b minus a. And if you realize and you look at that, that's the fundamental theorem of calculus in the top as an antiderivative of this. One is a derivative form, one's an antiderivative form. Mean value theorem says there's some place in there where the instantaneous rate of change is equal to the average rate of change. And this is equal to the average value of your function. Right. The question is, when does this apply? F of x must be differentiable on the interior. And they'd like to ask that question. Seen it a couple times. And they could be like Mrs. Hersman, who asks you the same question 5 times until you get it right, right? But you've seen some quizzes like that. And College Board can be like that. So when you look at the differential equation, the last differential equations we've had for the last 2 years were almost identical. Don't forget your chain rule. So you might want to study the bird problem and the waste problem. They may throw another one in there like that. So we think there's going to be a differential equation. Now, it's not every year they do a differential equation. I kind of hope they do, because those are so easy to prepare for. Separate the variables, integrate both sides. Yeah, all that stuff. It's very, you can memorize it. Now, here's the deal with the differential equations I want to point out that I didn't in the other class too. We did the waste problem. dw dt is equal to, as 1/5, I think, 300 minus w. First off, there's no t on the right side. That bothered you, and I don't know why it does. No? Remember when we have the population is equal to kp? There's no t in this one either. But when you separate and you integrate, the t will come into play then, but not in the derivative. There's no t in the derivative. But the problem with this one is when you integrate, because you're going to have dw over w 300 minus w equals 1/5. And when you dt Helps to have the differential there because it tells you what the variable is. So that's where the t comes in right here. And the problem with this one is because of that negative, that gets integrated wrong many times, probably more than 50% when I grade this. So if you do a u substitution, you will realize it's negative log of the absolute value of 300 minus w. Because of this negative w in there, you need to do a u substitution if you don't see it. Right, if it were w minus 300, we'd be okay. But if you do 300 minus w and you do du, that's equal to minus dw. So there's the negative sign. Well, here's the thing. You will get the point for separating. You will not get the point for integrating, provided it's only 1 point. You will get the point for adding c. If you put in the initial values, now don't solve for w first. Just get as many points as you can right now. That's the maximum you're going to get. So if you're on the exam and you integrate one of these pieces wrong, and you're not going to know that you did it wrong, or you might, but most likely you don't, then the answer point you're not eligible for. So what I would do if I'm doing a differential equation is get through my first 4 points, make sure I've answered everything else I can answer on the exam, and come back and solve for w. Because if you solve for w and that's wrong, you're wasting your time. You're not going to get anything for it. But you don't know that. So do that last. It's only 1 point. You separate. I'll write it one more time. Separate, integrate both sides. If it's not separated, you get 0. We're done. We don't even look further. Even if you put c in it, we don't care. And then you integrate both sides. Can't have mixed variables. Can't have mixed vegetables. I don't like mixed vegetables. Pardon? If I don't have the negative, I don't get that integration point. That was a hard problem because of that negative. No, that's on the right side. This is this side, so I would get 1 over u du with a negative out in front. That's got nothing to do with the t's. That's the other side. 1/5 dt. No, it's du dw. Because, whoops, I wrote that wrong. Du over dw, because that's the variable in question. If it's a rate, then I want du over dt, but that's not what this is asking. Okay, separate both sides, integrate both sides. What's the most important part right here? Because you're done if you don't do it. Add c. Substitute in the initial condition. Now, you see why we stress vocabulary? Because some of you got to this question, you said, I don't know what it's asking. It says solve the separable differential equation. I've been talking about it. Yes. No, you get the point for putting the values in the right place. So this was, what was this? I forgot what the values were. 20? I don't know. You still don't get any points once you solve for C. You don't get any points till you solve for W. And to solve this equation for W, before you can exponentiate both sides, you must divide by that negative 1. You must divide by negative 1. I don't know if it was W. I don't remember what the values were. So you have to put this in, like if it were 0, 20. And you must put them in the right place. Okay? So if you reverse them, you don't get it. They've got to be in the right place. Okay? I always hope we get these because they're so doable. And 2 years, the last 2 years, they've not had a T in there. And basically, it's just that equation with a shift. Well, it's got a negative, so it's got a shift and a flip, but that's okay. Still done the same way. That was tough. I'm not going to say that was easy. It wasn't easy. The bird problem was a lot easier. And when you take the derivative of this to find the second derivative, you must use the chain rule here. And if I put the dt there, you can see that's not negative 1. It's negative 1 times dw dt. Don't forget the chain rule. We haven't reviewed much of it lately. I'm a little worried about that. I'll be here in the morning. Okay, more things. The fundamental theorem of calculus. What am I up to, 7?
Is that all you have to do? Just those 4 steps?
And then solve. You should solve for W, solve for your function. But get as many points as you can. This is not right now, it's not just about getting, working through to get all the right answers. It's also about good test taking strategies, which you can take with you to college. Solve for Y and if time. So I would skip that and come back to it. But I'm random, so I can do that. Some of you are sequentials. That's really tough for you to do. I'll say, just skip it, come back to it. Get as many points as you can. Personally, I would do the DiffEq first. That's easy 4 points, provided you know how to integrate. Okay, and I've gone over that negatives, and I think you can get that right now. I've gone over it a number of times. The other big thing is the fundamental theorem of calculus. The integral from a to b of little f of x dx is equal to f of b minus f of a. Well, often they give you this, the integral from a to b of f prime of x dx. Well, that's f of b minus f of a. And guess what? What is that? It's, no, I don't have a denominator, but that is the total change in f. This is the total change in capital F. This is the total change in little f, whatever it represents. So in one case, it was temperature, so it was a change in the temperatures. Think of the context of the problem. I know it takes more time to do that, but it actually helps you. And in these problems, we also have the second fundamental theorem that might not be in this problem, might be in a later problem with a max-min. And the second fundamental theorem, we got to remember this. Do you remember this one? What do you mean the furthest? It's just from A to B. I don't care where it is. It could be backwards. It's okay. Okay, what's this going to be? F of x. Do you remember that? When they give you that g of x is equal to the integral from 1 to x of f of t dt, when I see that, I know I'm going to use that. It's automatic. And what does this represent? Signed area. So, and when I see that, I'm also will look at the problem and say, oh, I see a lot of geometry there. I see lines, circles, or whatever. So that's usually a geometry problem. Those are easy to get quick points on as well. The more you practice, the more you're going to be comfortable when you run into a problem that looks like that. Now, 2011 was really tough. Yeah. Not g of x, but g prime of x equals f of x, right? Because if I take the derivative of both sides with respect to x, there you go.
That's okay.
Yep. And you're going to see it. You're going to see it multiple choice. You'll see it on free response. Then what's g double prime of x? F prime of x.
We did that. We did this.
Yeah, we've done these. Noah? Is the equal to the integral. It's the area under the curve from 1 to x. If x is negative, it's backwards, and now it picks up negative values. Reversing it. Reversing the integral is a way to fix it, yes. Okay. What else will they put into here? They might put the maximum existence theorem here. They might not. Oh, what else I'd like to do is get Riemann sums in here. I think there's always been some sort of a Riemann sum. It could be left, right, midpoint, trapezoidal rule. Yeah, Golombeski sum. Actually, if you wrote Golombeski sum on there, there's probably somebody who's going to read your paper who knows who I am. I'm pretty well known, yeah. No, I just get to be well known. That's all. I'm not even going to go there. Okay, you guys? What? Yeah, Golombeski sum. No, I don't. Okay, you guys. Riemann sums. You guys know the difference between right and left? Okay. Okay, you guys. let's clarify this. Right and left. Now, that's an increasing function, and it's the increasing, decreasing that tells you if your estimate is an underestimate or overestimate. The tangent line is concavity. Okay, so let's put one in here. Let's put a left Riemann sum. So I'm going to divide this into 3 regions because that's usually what they have us do. And I'm going to find the height of my rectangle on the left side. Okay, Noah? This is a left Riemann sum. Over or under?
Under.
Under. I draw the picture. I'm just telling you it's the increasing, decreasing. So in the problem, if they say it's strictly increasing or strictly decreasing, you know they're going to ask you, is it an overestimate or underestimate? That's what you need to use. If they say it's concave up or concave down, or there's a way to find the second derivative to determine that, then that would be the equation of the tangent line. Is that an overestimate or underestimate? You read through the problem. They give you a lot of hints if you really read through them carefully. Okay, let's make a decreasing function and do a left Riemann sum. And I should get an overestimate. Now, have I memorized this? No. I just draw the picture. Oh, I see. It's the increasing, decreasing part I must memorize, though. Okay, that's decreasing. What about a right Riemann sum? A right Riemann sum means I'm going to come over here on my rectangle, use the right side of my rectangle for my height. Some of you misread, I don't know if it was this class or the other class, I gave you guys different problems. But some of you misread that and gave me the right Riemann sum when it was asked for the left. And now last year I believe was a trapezoidal rule. Probably going to be a left or right or midpoint. I would probably say midpoint. But then they can't do overestimate or underestimate. Now, if they don't give you functions increasing, decreasing, and they ask, is your estimate an overestimate or underestimate, Casey? They ask you that, or we don't know, that would be we don't know. It has to always be always increasing or always decreasing. So here's the trapezoidal rule. Well, they've changed how they do it. There's an exam that they give to most of you. They release that. And then there are others where they give them a different exam and they're not releasing that.
What do you mean others they give? So like,
Some other schools had different exams than what we had last year.
oh really?
They don't release those
Why?
because it's hard to come up with good problems.
That's true.
And if you notice, as we've studied these over the years, we've seen patterns.
Excuse the interruption again. Is Declan our art class?
Yes,
Could you send him to the guy?
Oh.
yes. Okay,
It's like the guys. Check for the substance abuse problem.
so should I put the tangent line on here? When do you look at concavity? Concavity will tell you if the tangent line is an overestimate or underestimate. Oh, one other thing while I'm doing this is they are going to ask you for the meaning of a problem. They're going to say interpret your results. Okay, so if I say dw dt is equal to -2, they might ask you what that means. Remember the waste problem? So, and maybe this is on the interval from 0 to 10 days or something like that. You must have 3 pieces here. Okay, girls?
Need units.
And it'll say with correct units. So maybe it's pounds. So in this case, this would be the amount of waste
You said the amount of waste is decreasing at a
is decreasing, yes, at a rate of 2 pounds per day, whatever the units are, I'll make it pounds. And that's not enough if you get all 3 pieces.
Well, it's only
And when? During the interval, or either, if this is at a particular point at day 2 or something like that, maybe that's what it is. I'm not very good at making these up.
1 point though.
It's only 1 point for all of that. So when I grade these, I don't like grading them, but I'm looking for 3 things. What does it represent? A rate of change. When is this happening? It might be an interval, it might be a specific time, and the units. I've always seen it was always 3 things that you must include. Noah? Oh, the tangent line. We could do that. We'll run into it, but I thought we'd do area volume. I'm concerned about position and velocity acceleration, so I thought we should maybe hit that tomorrow. Then tonight is area volume, but for those of you who are okay with area volume, I can come back in and do related rates. Because we kind of think there might be a related rate. And in 1997, if you did that 1997 problem, there was a related rate problem with a differential equation. Do you remember that one? It was that x to the fourth problem, finding the volume of this thing. It was 1997 FRQ. Related rate with a diffie-Q and with the fundamental theorem of calculus. They love to put those things together. But you know what? That's when things start to make sense. Now, you asked me, oh, so I could do related rates tonight if you want me to do related rates. So we could do that. I'm there tomorrow morning too. Because not everybody can come at night. I know that. I'm trying to think if there's anything else. I think that's a big piece there. So area volume would be just like them not to put it on this year's exam. Never have I seen it. I think you have a 99.9% chance of area volume. The review sessions tonight, 6 to 8. Plus, you can also go back to any of my videos. I've got them from last year. I think you are. That was that 97 one, yeah. That was a related rate problem. We can do those. We can do those tonight. Well, I want to get area volume because I'm pretty sure you're going to have that. And there's a lot of different things for area volume. You have to find areas. You have to do rotations. Now, around the axes is not a problem, but around other lines, that's a problem. And the cross sections. But actually, those are easy. So you got max mins, you got tangent lines, you got MVT, IVT. You know, if you look through this packet tomorrow, that's probably enough. Because by now, you should be pretty well saturated if you've been doing problems. Well, let's do 2012, number 2. Now, that's a calculator problem. They assured me in 2011 there would never be an area volume problem with the calculator. And then they did it to me. They said, we're not putting them on the calculator part anymore. So it was a little bit of a shock when I walked in there and saw that. I'm going, you gotta be kidding me. Only if they do it that way. They don't have to. Oh, don't do that to me. I hate those lines. They don't always do that. Well, that's better than usual. Okay. Now, tonight, Mrs. Hersman will hopefully we'll get through 2010, 12 and 2011. She'll do start at 2010 tonight. Tonight. Wednesday, you have your exam.
Is this calculator?
Probably down here. I don't have any rooms reserved, but.
Is this calculator?
Yes, this is.
Like need it.
Okay, we ready?
All right, let's do it.
The form for area volume, and then I can come down here, hopefully here. I prefer here because then I can do a recording. If I'm in the other rooms, I can't. So then I could do a recording for related rates if people come. Okay, I have the region bounded by the x-axis, the graphs of the log function, which is this one, and y equals 5 minus x, which is that one. I want to find the area of the region. How do you want to do this? Which way do you want to slice it?
This way. No, up and down.
We can do it both. Because guess what? In B, I have to do it vertically, and in A, I have to do it horizontally. C, I have to do it horizontally. So I got to do them both somehow, sometime. Everybody was okay with A and B, actually, for the most part last year. It was C that bothered them. Now, I've never graded one of these, so I don't know how they come out. Okay, so let's do it vertically. How many integrals am I going to have? This function is different than this one. I have to have 2 integrals. So we're going to have to get this on a calculator. Now, we've already done that, but we're going to do it again. That's correct. But guess what I have to do in B? I still have to, B, I have to do it vertically. Okay, we'll do it both ways. How about that? So to do it vertically, we will integrate from 1, and I name this point A comma B. Name it whatever you want, but because you only have to write it down once. And you get a point for writing down that ordered pair. So I'm going to integrate from 1 to A, and what function am I going to integrate on this one? Because this is just the y coordinate. ln of x, and then it's dx. If you don't put dx in, no penalty. But this is what it tells me, because what's this y coordinate? It's y2, this is y1, and this is delta x. So it's y2 dx, and dx tells me I want x's in there. Am I going to add these or subtract them?
Okay.
Look again. I'm going to add them. I'm going to add them because I want this area plus that area. So it's the integral then from a to, where is that? 5. Of 5 minus x dx. Yeah, we're going to do it the other way. If I decide to slice it horizontally, then what's the differential? That's delta y, isn't it? They're always opposite. If you see anything with shells, ignore them. We don't have to do shells. Okay, so this would be this x coordinate here, I guess I'm in the way, minus that x coordinate. So it's x1 minus x2 delta y. What variable do I want there? X or y? You want y's. So I don't understand how you can do it without the differential, quite honestly, because that tells you the variable you want. So I'm going to integrate x1 minus x2 dy. Should we get our limits of integration? Because we're going to slice it this way. We're going to start what value? 0 and go to what value? Not 1. Don't ever assume, especially if it's a graphing calculator, b. Now, the hard part here is you have to solve for x in terms of y. This one's not bad. Y equals 5 minus x, although that's probably one I mess up on. What's x equal to? 5 minus y. Okay, so this is going to be the integral of, and that's the bigger x value. It's 5 minus y,
I know that's the bigger one.
because it's further to the right. Your x values get bigger as you go to the right, right? And then now I've got to do this one. Y equals the log of x. What's x equal to? E to the y. Exponentiate each side. So e to the y is equal to x. So that's the other one. Minus e to the y dy from, oh, we did that, 0 to b. Now, you want me to go through the calculator with you?
We'll let you define that point.
Yes? Got myself. Okay. So you guys get your calculators out. I can clear mine out. Okay, I'm going to clear that. I've got my functions in there. Oh, I'm going to change that little circle thing, though. It makes it go so slow. Now,
Alright, so it's 0 to 1.3.
okay. On my window, they gave me a picture. Well, they go 0 to 5. I like to see a little more of that, so I went 0 to x. And the x scale I counted by ones. The y min, again, I like to see the y-axis. So I make it go below the y-axis, so it's -1 up to 2. And if you wanted to graph faster, change the x-res number up. I don't really pay much attention to it. There's my line. Whoops, sorry. And there's my graph. So what do we have to do? Find the intersection. I like this one, so I got to find both x and y. So second calculate, 'cause I can do it one time. You guys should be good at this. There's only 2 curves. There's only 1 intersection point. So just press enter till you get the answer, and there it is. Now, you need to write down all those numbers. They want to see them all. So you get a point for that. But now, which one do you want to integrate? The first one or the second? The second? Okay, because that's what I have. Now, when you integrate this, it's going to be FNINT. Now, well, you could go alpha y, but you know, they're dummy variables. Why don't we just go 5 minus x? But don't forget your parentheses. Minus e to the x, comma, x, comma, 0, comma, b. Now, before we do that, I want to show you the shortcut. You could write it all down and type it all back in again. And if you type it in wrong, your answer is going to be wrong. So that's a problem. Because we are starting on the y-axis. Yes, that's correct. Now, what I'm going to do is store this. I don't want to remember 1.30655. So what I'm going to do is I'm going to quit, and I'm going to take the x, because I might need the x for later on. I might not. And I'm going to take x, and I'm going to store it. If I press enter, you see I've got the x value there. Store it into alpha a. I can store it anywhere I want. Now it's permanently there until I change it. Where should we put y? Now, where is y on here? It's alpha 1. Let's store that into b, alpha b. Now, when I integrate, I'm going to clear that out. You go to math, 9. Okay, now I got to type this in. It's 5 minus x minus e to the x, comma, whoops, got to close those parentheses though, comma, x, yeah, if I don't do it here, it'll give me a syntax error, 0, comma, and then alpha b. You can use, I would, but most people don't have it, so I'm not using it. Now that parentheses it doesn't care about, but I'll put it in anyway because I like to be right. And there it is. Okay? That found the area of my region. It's just part A. Yep. So if I go back here, you can see how many points we get. 3. It's usually 3 for the area. 1 point for the integrand. Now here's this. If you did this way, you'd have to have both of those. And then 1 point for your limits. So basically 1 point for knowing these values. One or the other. Give me both. Not a problem. And 1 point for the answer. So that wasn't so bad. Yes. Yes, you must integrate it. Unless you can integrate it by hand, and you can't integrate the log. Now, you could integrate this one by hand, because that'd be 5y minus y squared over 2 minus e to the y, evaluated at 0 and b. Then you have to put your values in, and then you could leave it. But if you're going to use your calculator, like you can't integrate the log of x, you must use your calculator and integrate it. So if your calculator dies or something, and you could do it the other way where you can actually integrate it, you could do that and get away with it. But if it's something you can't integrate, you're going to have to use your calculator. Okay, next, I go to find the value, and then you go store. STO is. Oh, I don't have my.
It's right above on. Right above on.
Yeah. Okay, this part bothers you. I don't know why it does. I love these parts because these are squares. They're easy. Easy, easy. No. Think of them as easy. It says the cross, where's my iPad? There it is. This is not a square, but it's close enough. They are coming out at you. You know what? I never know what any of these things look like anyway, so what do I care? They're coming out and they're perpendicular to the x-axis. Read the problem twice. Could have been y-axis. I would have preferred y because then it would have been less work. But no, they had to do x. So they're coming out at you. Well, this length here is the side of your square. Right? And what's the height? It's still the same, isn't it? If it's a square. Now mine's a rectangle. They have to give you what this is, 3 times that side. They have to give this to you. If they give you cross sections and they say the area of this cross section is whatever it is, that's even easier. You just integrate it with respect to whichever axis is intersecting or being, with respect to. Okay? So that's nice. I like that. So, but this one is the area for one of these slices is side squared. So the volume is side squared times, in this case, dx. Yeah, so there's no pi. Why?
That's not a circle.
Because we didn't rotate. Okay, so there's no rotation in this problem at all. And if we don't get through it today, I'd like to finish up tomorrow to do the ones with the rotations in them. Now, Mrs. Hersman will do 2010, which has a rotation in. We'll get to 2011, maybe part of it, but maybe not to the rotation today. Okay, so how do you find the side? It's this y value minus 0. Okay, I gotta get myself. Yes, 6 to 8. Okay, so B, I'm going to integrate, and what was that side? Should I go back up?
What side?
What is that height?
Oh, it's
Right, it's the same as this one, but it's the log of x. And how tall is it coming out at you? The log of x, because it's a square. So it's the log of x squared. Dx from, same limits of integration too, 1 to a. And then what do you have to do? My shape changes, doesn't it? I mean, I have no idea what this thing looks like. It's really weird. And then you have to do these rectangles. So it's plus that integral. But this side, that's only the side. I want the side times the side, so it's the side squared. Plus the integral from a to 5 of 5 minus x squared dx. Did I get that right? Yeah. Colin question. It's just geometry. That's all we're doing. This is the side, and think of a deck of cards. They're coming out at you. If I only had one of those 3D pens, then I could draw it coming out at you. So that if I look at the cross section, it's the square. Well, that side and that side are the same. They could be circles, in which case then you have to be really particular about how to get your radius. And then this thickness is either delta x or delta y. In this case, it's perpendicular to the x-axis, so it's delta x. Length, width, height. So they give you an area, they tell you the area of the cross section is some function. You have the length and width, now you just need the height. I think it's 3. Let's go back and see. We don't have to integrate. Okay, 2 points for the integrants, probably 1 for each, and then 1 for combining them and probably having the right limits on there. That's 6. That's not so bad. Okay, now we're going to come back here. This one's kind of weird, but I want to, now you guys, what kind of line is this? It's horizontal. And there's going to be a line here. Oh. And we're going to move this line so it divides my area into 2 regions with equal area. Looks like about there. Well, maybe that's too big, isn't it? Okay, so that's y equals k. So guess what you're going to do? Can I do it right here? You're going to integrate the y's. So it's the same one we have where was it?
right there.
Right here. It's going to be the integral of 5 minus y minus e to the y dy from 0 to where? Okay. Well, silly me, I just do it this way. It's equal to the integral from k to b of the same thing because they're equal areas. That's one way to do it. B is this number. So then I integrate from here to here. Or could I just integrate and say it's half of whatever area I had, which was 2.89 something? What was it? Oh, 2.98. At least 3. You can do more if you want, not fewer. Because if this divides it into equal areas, then this area is half of the whole thing. Make sense? These areas are equal. I could just set the areas equal, which is what I did, but I know this area, they're both right. I know that area, it's half of that, if they're equal.
So you could just do the answer to A divided by 2.
Yes, but you still have to have that integral over here.
Okay.
You still would have to have this piece. I didn't think of it that way. I just said, oh, if it's divided into two equal areas, the area from 0 to k is the same as k to b. Doesn't matter. They're both. It's mathematically right. Yes. Or you could say the area we found in part A. Somehow you got to refer to it. They actually put the numbers in, but there's a variety of answers that we can get. And that's 3 points. My goodness. Let's do 2011.
How did you get,
If you get 6 out of 9 points, you're doing great. Now, you get 9 on this, but you only get 2 on the next one. So be it. You're still okay. Have confidence as you do these. I know you have them. You've learned everything you had to learn. Confidence is important. So let's do 2011. Now, we don't have 15 minutes, but we'll do what we can. This was without a calculator. 2010, they said, we're never going to have calculators again for these kind of problems. So sure enough, they did it right in 2011, and then 2012 comes around, and they make it a calculator problem. I'll ask them again this year.
what? No.
Oh, this was question 3. Now, question 4, that is a tough question. That's the one with the G prime and the max mins. And actually, it's not. You wouldn't use the max min existence theorem, although it's exactly what I do every year when I teach it. Because that's the logical way to do it. Whoops. Which number is this? Now, number 2 is the particle motion problem. It's a calculator problem. Number 1, I mean. There it is. I can get it all squished on here. Okay. Now, this is without a calculator, so you have to integrate by hand. Oh, it's not even doing area. Write the equation of the tangent line. How do we do that? Okay, they have to give you everything. I want the tangent line to the graph of f at x equals 1/2. Oh, it's right here. Whatever that is. Okay, guess what? No. Because this is the sine function, and the other one is 8x cubed. No, it's y minus, oh, I got the wrong marker. F of 1/2. Careful. No, oh yeah, it is. Equals the slope, which is f prime of 1/2, x minus 1/2. And they gave me the 1, but if I didn't have the 1, I could figure it out because it's f of 1/2, which is 8 times 1/2 cubed. Well, if f of x is this, what's f prime of x? 24x squared. So what's f prime of 1/2? I like to write it out because I like to get it right. Plus, I get my point there. Of course, if I do it wrong, I take the point back. But so that's 6, right? No, it says just f. So it's y minus 1 equals 6x minus 1/2. No, it said write it. I could. No, I couldn't get the slope right. What's true about the slope at that corner? Are they the same? No,
Let's see. Here.
the slope at this corner, even though they're at the same point, I kind of like that. It's not the same. So I want the tangent line there. For whatever reason, I don't know. Okay, how do you want to slice it to find the area of R? Vertically or horizontally? Vertically. I do too. I don't want to solve for x. Do it horizontally, you got to solve for x. Oh, that's easy. It's y1 minus y2, and is it delta x or delta y?
You know which way to do it.
I can do it either way, but if I want to do it this way, I have to solve for x in terms of y, and I have to solve for x in terms of y, which means now I have an inverse sign, and if I integrate it, I'm in trouble. I can't do it.
Well, how do you know like which way to do it before you don't have to solve for it?
Just draw the picture. This is delta what? X, right? I want my x's in there. Y is in terms of x's already. Had they written x equals 8y cubed, I would do it the other way. You just have to think about it. Okay, so B, I want to integrate. I want the top one, which is the sine of pi x dx, minus the bottom one. Forgot that one. What's the bottom one? 8x cubed dx from, where are the x's going from? 0 to 1/2. Nope, this is a non-calculator problem. That's the problem here. So how do you integrate? You won't have any problem integrating 8x cubed. By the way, 2 points for this. This is 4 points. Okay, guys? How about if we do a u substitution? U equals pi x. And what's du? It's pi times dx. Review those u substitutions. They'll be in the multiple choice part of the exam. So that this is the integral of the sine of u du. What goes out in front? 1 over pi. Do you want to switch the values of the u's? Do you want to make that u's or go back to x's?
Why is it 1 over pi instead of pi?
Because solving for dx gives you 1 over pi. Okay, so dx is 1 over pi du. Just algebra. Okay, if x is 0, what's u? 0. If x is 1/2, what's u? Pi over 2. Right. Okay, now if we integrate it, what's the antiderivative of the sine function? Positive or negative? Negative cosine of u.
How'd you get pi over 2 again?
Because u, these are the u values. You got to switch it. They might ask you that in the multiple choice. Can't leave it 0 1/2 because those are x's. So this is 1 over pi.
How'd 1/2 put pi over 2?
Because when x is 1/2, you put 1/2 right in here.
Oh, okay. Yeah.
Okay. Now this is negative cosine of pi over 2. You may leave that as negative cosine pi over 2. You do not have to evaluate it. It's kind of interesting. And then it's minus a 1 over pi, negative cosine of 0. Again, you don't have to evaluate that. Does anybody know what the cosine of 90 is? 0. Remember to review your trig. It's how I do it. What? It takes me, what, a second? That's 0? What's the cosine of 0? 1. And it's minus a minus. Tomorrow, we will do the volume. 4 points for that one. I didn't finish it. I still haven't done that part. Then I have to integrate this, which will give me 8x to the 4th over 4 evaluated at 0 and 1. I didn't quite finish it. It's right down here. 0 and 1. I mean 0 and 1/2. Sorry. Then we'll do this one. Those are the toughies. We'll start with that tomorrow.